Welcome to our second lesson in our machine learning and AI course. This is a very powerful course that is designed to make you an AI engineer, a machine learning engineer, a data scientist, and a data analyst with machine learning skills. This course will revolutionize your world because this is a course that is ruling the world today. Anyone who has knowledge in AI and machine learning has a place in the future because very soon a lot of people will be expected to have this knowledge. A lot of people will be expected to have this knowledge. And if you start now, you will have a lot of advantage. A year from now, you will wish you had started today. And I'm super excited that we are starting today. And a year from now, you are going to be good in this field. The tech world is going to change. A lot is going to happen in the next few years. And those who align themselves with AI and machine learning will have a lot of advantage. So I'm very, very excited that we are doing this. Let's focus on it because when you focus on it, you will grow in it. And today's lesson will be about the types of machine learning. In our previous lesson, we were introduced to machine learning, and amazingly, we were able to build our first AI model. If you missed that lesson, look for the lesson one, and it's going to be really, really fun. And today we want to move forward. We want to add to our knowledge. We will keep adding till we are experts in this field. We are not going to leave anyone behind. We are all going to become good in this particular field. What you focus on grows. So today, it may be young, it may be small, but let's focus on it. Let's build our knowledge and skills in this field. Let's plant the seeds of AI and machine learning. And very soon, we are going to be strong people in this field. Today, you may be a little plant, but very soon, you are going to become a great and mighty tree and a leader in this field. Wow, AI is the future. Our goal here at Rita Africa is to be the leading data analytics and data science team in Africa within the next 3 to 6 months by building a strong foundation in data skills, mastering cutting edge techniques in Python, in SQL, in machine learning, in Pandas, in Tableau, in Power BI, and all the relevant skills that we need, leveraging innovative tools and leading Africa's AI research and development. What we are learning here, we are not just learning it for nothing. We are going to use it to make an impact on the continent, to drive success across various industries on the continent of Africa. And so we are going to take a real look at what AI is. We are going to look at what artificial intelligence is. In our previous lesson, we started introducing and discussing it. We'll do a short recap of that, and it's going to be short. And we will get into the types of machine learning that we have. And when you hear machine learning, don't be confused at all because machine learning is artificial intelligence. As a matter of fact, over 90% of the AI you know of today, as AI is spreading everywhere, over 90% of the AI you are aware of is machine learning. So when you hear machine learning, it is a synonym to AI. It is AI. It is AI. It is just a subset of AI, but it is within AI. So machine learning is AI. I want you to put in the chat that ML is AI. ML is AI. So when you're studying machine learning, you are actually studying AI. So what is artificial intelligence? This is so powerful. It says that artificial intelligence is a branch of computer science. I like that already. It is a branch of computer science. So anyone who studies AI is a computer scientist. You are studying computer science. In the broad scope of the discipline called computer science, artificial intelligence is a branch of computer science. And it is the branch of computer science that aims to create machines that perform human-like tasks and mimic human intelligence. So the goal of AI is to create machines with human-like intelligence in a way that machines are no longer given explicit instructions, but machines are given the ability to learn, the ability to act, the ability to decide, and that is a whole new world. I actually got into AI, started a serious studies and encounter with AI in 2017. Yeah, 2017. That's when I started teaching about AI. That's when I was actually hit by what AI is able to do at that time. And the first time I actually saw what AI really was and how it was working, I was blown away. What I was introduced to, what I was exposed to, really blew me away. Machines are coming with human intelligence. And there are various techniques to make this possible. There are various techniques to make this possible. One of the techniques is what we call ML. One of the techniques is what we call ML. If you look at this diagram, you can see that ML is within AI. And so ML is not out of AI, ML is AI. What is ML? ML is the subset or the aspect or the part of AI or the technique of AI that creates intelligent systems using data. In this particular field of AI, we focus on using mathematical and statistical algorithms to learn from data. There are various techniques to achieving AI. One technique is to use data. Data is powerful. Data rules the world. Data is everywhere. And data is what becomes information. And so in the field of IT, data is so powerful. That is why those in the data field, if you really understand what data is, you can rule the world. And so there is an aspect of AI that creates intelligent systems using data. And for that to work, we use algorithms that are already created and designed to learn from data. These algorithms, they have been created and they have been designed to have the ability to look into data and pick information and find patterns and understand trends and be able to make a prediction out of what the data says. These algorithms are so powerful, and if you study statistics, you are going to see that there are a lot of statistical formulas that can be used to predict a lot of information. And these statistical formulas have been made so powerful that when they are trained on data, they become intelligent systems that can make future predictions. And so any aspect of AI that deals with data is machine learning. So when the AI is trained with data, it's called machine learning. Now, we will be introduced to a lot of algorithms because it is these algorithms that we use to build the machine learning models because we use them and we feed them with data. We will be introduced to multiple algorithms, but there is a very powerful algorithm that has been created to be the greatest of all of the algorithms. This particular algorithm was actually created after the human mind. Scientists have studied the human brain, the human brain, because when you say mind, it goes beyond your brain. How the human brain is wired, how the human brain is able to make connections, how the human brain is able to process information and store information in a super complex way. In today's world, one algorithm has been created like that. This particular algorithm, we call it neural networks. If you can hear me, please type it in the chat. We call it neural networks. We call it neural networks. Neural networks. If you can spell it, just spell it like that. Neural networks. That's powerful. Thank you, Marasi. This neural network is different from all the little algorithms we'll be learning about. This is a super powerful algorithm designed to be like the human brain, and it does complex things. Now, when you get into training data with this particular powerful algorithm called neural networks, you actually move into a whole new realm and a whole new aspect of machine learning that we refer to as deep learning. We refer to it as deep learning. So it is all machine learning, but when you use neural networks to do the training, then we call it deep learning. Deep learning. Please type deep learning in the chat. And if this is the first time you are hearing deep learning, this is actually where you want to get to when you become a senior in AI. This is where you want to get to because this is where the powerful AI systems are. This is where the greatest AI systems are. The powerful AI systems, you know, they were created with neural networks. Like ChatGPT, it was created with this in a complex way, and sometimes there are multiple neural networks combined to create super complex models, and we call them large language models, and they are so powerful. So as we begin this journey, we have a future where we are going to move away from basic machine learning to the field of deep learning. I want all of us to make that decision to advance our knowledge to the level of deep learning, because by the time you get there, you yourself will be super smart and you yourself will be able to learn complex things and you'll be able to do complex things. Yes, so let's follow this exciting field and let's become powerful in our studies. Machine learning is a field of AI that allows computers to learn from data. And so when it comes to learning from data, we call it ML. After the computers learn from data or the algorithms learn from data, they are able to make predictions or decisions without instructions, And so, although traditional software development is good, today we have entered into a field where we decide not to give instructions. It's not that we cannot give the instruction, we can, but we have seen that instructions have limits. This time, let's not give instructions, but let's use a different approach. The different approach is to allow the computer to learn how to do. Instead of telling it what to do, you are now teaching it to learn how to do. And that is a different story because the computer is super fast. The computer can be made to be super fast, and the computer can do billions of things in a second. And so once the computer gets the clue, it can multiply that effect at a rapid rate that what humans cannot do, these computers will be able to do. The goal of AI is not to take over humans, but to work with humans so that things that are repetitive are too time consuming, things that do not, is not supposed to be done by human efforts. We use these machines to do them so that AI and humans will together become more effective so that humans will focus more on what humans do best, and the machines will also focus on what we don't want to do. This is the goal of AI, so that the things we don't want to do, there are some things you don't want to do. Let the machines do them. And the things that you have to do as a human, then you have more time to do those things. Today, AI is used in the real world. Years ago, when you talked about AI, people couldn't relate to it. I remember in 2017, when we started teaching AI, we had to explain and explain and explain and show a lot of videos for people to understand. Today, everyone knows about AI. Today, we find AI in Netflix and YouTube through recommendation systems. This means when you start watching one type of video, the AI can predict what video you are likely to be interested in. Even though you've not watched it before, even though you don't know about it, the AI can recommend it to you because it is studying your footprint. And out of that data that is being recorded, it can use that data to make a prediction. The same way we're able to predict house prices through the model we created, there is a model that can predict the next video you are likely to be interested in. Today, we have self-driving cars. Years ago, if you had talked about cars driving themselves, you will spend a lot of time explaining yourself. But today, it is so common. It is so common. And these self-driving cars actually get on the streets. They drive on the road with other cars, and there are humans in other cars, and there are certain cars with no one. The cars are able to see other cars. They are able to see the road. They are able to see humans. When it's time to brake, they will brake. If an accident is approaching, they will stop. They are able to drive and deliver things, pick people without human directions or control. In the field of finance and banking, AI is used to detect fraud and other banking tasks. In healthcare, AI can be used to and is used to diagnose diseases and for medical imaging. And of course, AI is used in multiple chat systems today that some people cannot even live without today. Some people cannot live without these chat systems today. And who can mention some of them? Just mention one of these chat systems. We have ChatGPT, and let me see which one you use. Let me see which one you know. DeepSeek, Gemini. Elon Musk has one. I don't know if you've heard of it. Microsoft Copilot. Just mention some of them. XAI, Grok, Claude. All right. So there are a lot of them. There are a lot of them, of course. Meta AI is there. All right. So we've already mentioned this, so we are going to move on. So someone will ask, a beginner will ask, so how do we create these AI models? We use what we call algorithms. These algorithms are formulas. If you know Python, they already exist in Python. You just have to import them and then you train them. What do you use to train them? Who can tell me what we use to train the algorithms? We use what? Data. Thank you, Robly. Robly is back. We use data. All right. And so there are three keywords here or three terminologies here. We have algorithm, we have data. After the training in this field, we call it a model. So the term model is the intelligence system you have created, the AI model or the machine learning model you have created. You create it by choosing an algorithm and training it with data. As a data scientist, your job is to learn how to choose. You see, how to choose the algorithm, and then how to train and perfect the training. Once you do that, then you have a model that you can deploy into applications that can change the world. This is the future, and this is what we want to do. Now, these models or these algorithms, and sometimes algorithms will be interchanged with the word model. And so you have to look at the context very well so that you know whether we are actually talking about an algorithm or a model. These algorithms are complex mathematical formulas created over decades by statisticians, mathematicians, and computer scientists to be able to analyze data, identify patterns from data, and make predictions from data. Machine learning relies on these algorithms and models. You can see that here we are also almost using interchangeably, and they improve over time with more data and training it with more data. Examples of these algorithms are what we call linear regression. Please type linear regression in the chat for me. Linear regression. Linear regression. And if you know what linear regression is, it is one of the first algorithms that you'll be learning as a machine learning engineer and student. And if you are new to this, you need to start making room for these algorithms and making room for these terminologies that we use in machine learning. So we have what we call linear regression. It is one of the most popularly used algorithms. And once you feed it with data, it can make predictions for you. We have another algorithm called decision trees. Decision trees. And today we are going to be using another algorithm called logistic regression. Please type logistic regression in the chat for me. Logistic regression in the chat for me. Logistic regression in the chat. And we'll be mentioning other algorithms as well. All the pictures you are seeing here are different algorithms that very soon you are going to really understand them, and you are going to be using them to create models to solve problems in companies. The skill we are learning right now, others are not learning it. So we have a lot of advantage to get ahead and know these things so that very soon we will earn from them. Like I mentioned, when you learn, you are going to earn from them. Later on, we'll move on to neural networks for complex pattern recognitions, and all of which rely on concepts from statistics, algebra, and calculus. Each algorithm has a different approach to analyzing data. And so today we are going to look at logistic regression. We've seen linear regression. And so we know when to use linear regression when we want to make a future prediction. It's so powerful. If you want to make a future prediction, just call linear regression and train it with some data. The data that has been collected and well prepared, you train it, and then you have a model that can predict the future. Wow, this is so powerful. And we use linear regression when we are dealing with numbers, numerical predictions. So if you want to predict a price or you want to predict any numerical value, linear regression is a great model to use, a great algorithm to use, okay? Sometimes you'll be hearing algorithm and model used interchangeably, but then the model is when the algorithm has been trained. Then it is now called a model. All right. So each one has its purpose. And when we look at logistic regression, you understand why we didn't use linear regression, because what we want to do with logistic regression, linear regression cannot do it. So we need to use logistic regression for that. Yeah, so each one has a different approach to analyzing and making predictions from data. And different tasks requires different algorithms. That's so powerful. All right. So we've already mentioned that these are pre-existing algorithms and they go through a process called training. So if you want to create a model, you train. We use the term training to train the algorithm and it becomes what we call an AI model. All right. So after you have the model, then you can provide it with new data. This new data is not what it was trained on. This is data from the world, the real world. This is the intelligent model you have created. And it is able to receive your new data and make a prediction for you or give you an output. Because once you train it, it becomes a machine, a powerful machine that can receive new data and provide you with results. After training, the model can analyze new data, generate insights, make predictions based on what it has learned. Today, people are learning this and people are building massive models. People are creating a whole lot out of this. In the news, you hear a lot of models about models, and all these things, they were created the same way we are learning about them. So we just need to move on and create them. So in our previous lesson, we actually worked on a demo project, and I was so happy about that project. If you missed it, watch the previous lesson, and we were able to create a model to predict house prices using linear regression. And it was very, very simple. This is the code we used. And let me quickly run over it just for a few, 1 or 2 minutes, and then we will move on to the types of machine learning quickly. All right. So just like we learned about pandas in our Python classes, to create a machine learning model, you need to introduce pandas because you are going to be dealing with data. You need to introduce pandas. And then there is a particular library that has a lot of algorithms that is used in the field of machine learning. It is super popular. It is called scikit-learn. In code, we call it sklearn. But outside code, you are going to be hearing scikit-learn. So this sklearn, you can allow it to give you a linear model, and you can import linear regression from it. So this is actually what is going to do the magic in this particular project. We were able to create this. And again, from today, any project you work on, save it as part of your portfolio. Employers will look on them. If you have done this before, you have a great advantage. When it's time for interviews, people will bring a lot of CVs and they will talk a lot about what they can do. But employers want to see what you have done before. And when they see what you have done before, your CV is not even what carries the weight. Your CV is not even what carries the weight. It is what you've done before that carries the weight. Some of the best employment I got in the past from powerful companies, it was through what I had done before, not what I said I can do. And just like I mentioned yesterday, there are a lot of employers who will not expect you to know everything, but they just want to see that you've done some things before. Because most companies will take you through another orientation of what they do for you to understand it. But they expect you to have the basics and to prove that you've done some things before. Once you have some proof, it is very easy. It's very, very easy to get it. And sometimes looking for qualified people is really hard. Although you may be thinking you need a job, companies are also struggling to find qualified people. And companies don't believe people when they say they can do things. But when they can see that you have this, plus you have a certification, globally recognized certification, you have a lot of advantage. So the projects we will work on, publish on LinkedIn, tag Rate Africa as your source, publish on GitHub. And when it's time for employment, showcase your portfolio. All these things are important. You can see them as simple projects, but they are super, super important. So please be saving the projects and build your portfolio. All right, back to this particular line. So over here, we were able to call scikit-learn to import linear regression because we need an algorithm for the training and we wanted scikit-learn to give us one of its algorithms. Later, you realize that logistic regression will also come from scikit-learn. A lot of algorithms will come from scikit-learn. So scikit-learn is a powerful library that has a lot of algorithms that can be used for machine learning and is used in the industry. All right, so after we imported this, we actually used pandas to load the data. So if you remember yesterday's class, you can use PD, which is the alias of pandas, to read CSV because your data is in CSV. The data can be saved directly on your system and in the same location as your Jupyter notebook, or you can load it from GitHub. To load it from GitHub, make sure you load the raw format, and then pandas can read it into a data frame. So this is our data frame, and we are calling it data. And so the entire data is handed over to this data frame. And over here, you can see that we were able to split it into features and targets. So one of the important things you will get from the previous lesson is that when it comes to making predictions, you need to split the data and create one particular series here, which is called the target or the output. Now, this particular output that you have splitted, you have a purpose for it. Number one, you will use it to tell the algorithm how to get the right answers because the output here has some right answers or has the right answers. And the right answers will be used to train the model. And so after it receives its inputs, it will be given the correct answer. Why do we give it the correct answer? Who can tell me why we give it the correct answer? Because over here, you can see that we have X here. This X here is another variable here that is used to provide the inputs. And so with our data frame here, if you run this data frame and you check this particular data frame, what you are going to realize is that the data frame is made up of 3 columns. We have size of the houses and locations, and then we have price. The model we are trying to build is supposed to know how to predict prices in future. It is supposed to know how to predict prices in future. And so we intentionally train it with correct prices today. Now, for you to train it with the correct prices, you need to split the data and separate this particular column into a series and call it Y. So in machine learning, we call it Y, and you can see that it's lowercase y. It is also referred to technically as target or output. Then the rest of the data is provided as input. This means the algorithm will be receiving inputs in future and will be predicting the outputs. So from this data set, you can see that the size and the location of the houses were fed into the model and they were used to train it. The reason is that in future, we are also going to do the same thing. In future, what we are going to do is that we are going to, in future, we are going to provide size and location, and we'll be expecting the model to tell us the price. And so, as machine learning engineers, you have to engineer the model to know that we have inputs and we have outputs. I am going to feed you with a lot of data, and I'll give you a lot of inputs, and then I will tell you their correct outputs. And why am I doing that? And Robley says that for training purposes, because we want the model, the algorithm to be able to learn. Because in future, we are going to be asking this question and we'll be expecting this answer. Now, in machine learning, you can see that we use capital X for the features. Technically, these are called inputs and they are also called features. And we use capital X here because the capital X represents a data frame. So if you have studied pandas, you know that we have data frames and we also have what? Who can tell me the other data structure? We have data frames and we have series. Thank you, Robley. Robley is so fast. All right. So you can see clearly that this is a data frame. If you remember yesterday's class, you can see that this is a data frame. And then the output here is a series. And the entire data set, we store it usually in a small variable called X. Even though X looks small, it carries all the data sets. If there are 10,000 rows of data used for the training, they are all stored in X. After this splitting, when you call X, X may not be that small. It may have a lot of data. And then we also have Y. After this step, we move to another step where we actually create the model. So over here, you can see create and train the model. And to train the model, you need to call your linear regression here. You need to call your linear regression with parentheses, like a function. So when you call this linear regression, assign it to a variable. And we called it a model. Now, this variable here is the linear regression, is the algorithm. This variable you see here is the algorithm. How did we get it? We just imported it, that's all. But then the next step was that we called this algorithm, and then we called the function or the method .fit. Please type .fit in the chat for me, .fit. So when you are learning to build machine learning models, you are going to see this method here called .fit. And this .fit is very, very powerful. I like those who added the parentheses because it's a function. It's a method. This .fit that we get from this particular model is a powerful instruction that is equivalent to this word. I don't know if you can see what I'm writing, but if you can see what I'm writing, please type it in the chat for me. If you can see what I'm writing here, thank you very much. The .fit is an instruction. You are saying that model, train. Another word is what we said last week. This is it. This is another adjective we can use as a synonym. This one says learn. So this instruction you see here, so simple like this, is the most powerful instruction we have given. You are saying that model, learn. You are giving a direct instruction that learn, because this is where the model is now made. The model is going to ask you, what should I learn with? What should I use to learn? And then you tell the model that I'm going to provide you with X and Y. Who can tell me what X and Y represents? What does X and Y represent? If you know what we are talking about and you are not lost, what does X and Y represent here? This X and Y represents the features and the target, input and output, or in other words, it represents the data. So all the data that we use for the training, and actually in the real world, when we are training, we don't train with 5 rows, just like we used here for our first model. We just use 5 rows of data to train it. It was because we were just starting. But you can use 10,000 rows to train, and all the 10,000, you have stored them in X and Y. So the X and Y we are providing to Fit is no joke. It is the entire data set. The X represents the inputs, or what we call the features, and the Y represents the answers or the output. What you want the model to know how to do, or what you want the model to predict in future. But then you provide it to the model and tell the model, learn. In Python, which method do we use to instruct the model to learn? Who can tell me? In Python, which method do we use to instruct the model to learn? Is .fit. Thank you very much. So when you said .fit, you are actually saying learn. Then you provide the data. The data is what you see here, X and Y. Very powerful. And this is where the learning takes place. That training that we talked about, this is where it takes place. This is where the model becomes intelligent. After it becomes intelligent, now we can use it. How do we use it? We can use it to make predictions. So the last line here, we are now using our intelligent AI model. We came here and we said, model.predict, model.predict, model.predict. So here you are about to ask the model to make a prediction. because the model is now intelligent. This thing you see here is now AI. This is AI already. So you can use it. Why are we telling it to predict? Because we are building a linear regression model, and linear regression is used for predictions. So we can tell it to predict. But what do you want me to predict for you? We are going to provide a data frame. This data frame is the same one we gave it here when we are about to train it. We gave it size and location that in future, this is the question I'm going to be asking you. And when I ask you, what do you give me? You give me a price. In future, I'm going to be asking you this, then you give me this. So now that we are ready, this is what we are asking. We are asking for size and location. And when we do that, it is actually going to tell you that this is the answer here. So if you run this in Python, you are going to see the answer and you will be shocked that you too have built AI and it can predict. And what I like is that it predicts as an array or as a list. And so it is always having this square brackets here. Let me explain it. Anytime you run the prediction, you will see it as an array. Array means it is like a list because someone will ask, why would they predict as a list? Because it has been designed to predict multiple outputs at the same time. The same way it was trained with multiple data sets, it has been designed so that it will have the ability to receive more questions or more features or more inputs. Let's call it input. And it can predict all of them at the same time. This time we are doing just one prediction. So we say index 0, meaning that out of your array, out of your list, pick the first one for us as the answer. So if you want to see the prediction, you have to say index 0. If you don't put index 0, you are going to see the array with the brackets there. So if you say index 0, it means the first one. It makes sense because we just asked it one. So our answer will be in the first index of the array. And so when we want to print and we put 0 here, we know why. Because after the dot predicts is executed, the output of the dot predict is an array. So if we are expecting just one answer, it will store it in index 0. I know that some Pythonistas understand this. So this is where I ask my first question. Does anyone understand what I just said? Okay, thank you. So the answer comes as a list. So whether you are expecting one answer or three answers, if you're expecting one answer, you still have to ask it to give you index 0 because it will store it in the first index. So how many lines of code here? 1, 2, 3, 4, 5, 6, 7, 8, and 9. With less than 10 lines of code, you can build AI. This is AI. Now, someone said, my model is not super intelligent because when I asked it a question, the answer is not very precise. Even if I repeat from the training data, the answer is not too precise. And the question is, why is the model not able to give you a very, very precise answer? Who can tell us why the model is not able to give you a very, very precise answer? And the answer is because during the training, you only fed the model with 5 rows of data. Very few. There is no AI model trained like this. So if you create that model, the model will have some knowledge, but it won't be perfect. So what do? The only way is to train it with more data. Train it with more data. And someone said, okay, if I keep using it, will the model become more intelligent? And the answer is no, it won't become more intelligent. Why won't it become more intelligent? Because it was trained with little data, so it only knows little. So even if you ask it 10,000 questions, it will give you 10,000 wrong answers. So why do we say that it can learn and continue to grow with more data? When we say with more data, we are not saying with more predictions. We are saying that with more training. This means you can continue to train it. As you get more data, you can keep feeding it and keep training it and keep training it. Look at ChatGPT. We started from GPT-1, we moved to GPT 1.5, GPT-2, GPT 2.5, GPT-3, GPT 3.5 in 2019. That was when the world got to hear about it. When it got to GPT 3.5, what were they doing? They were training it. But it started with GPT-1, and GPT-1 is also intelligent, but it is not as intelligent as GPT 3.5, which was also making a lot of mistakes. Even 3.5 was making a lot of mistakes until GPT-4 came. So it becomes more intelligent with more data, not because of the output, but because of what? Who can tell me? Not because of the output, but because of what? Who can tell me? Because of the because of the training, because of the input, because we will continue to train it. We'll continue to train it. And later we'll start using a term fine-tune, fine-tune. All right. So this is a quick recap of what we did in our first lesson. And we want to quickly get into the content of this particular lesson. And we are going to look at the types of machine learning. We are going to be introduced to the types of ML, this particular ML that we've heard about, that it is AI. It is actually AI, and it is a subset of AI from data. We are going to hear that there are 3 types. And out of these 3 types of this ML, we are going to see how these 3 types of ML work, because we are saying that they are able to learn from data, but there are 3 types of them. What are the 3 types? So let's take a short break. This time we are going to make the break. You know what? Let's take our 10 minutes break. And after the 10 minutes break, we will go through this. Please make sure you learn. Make sure you learn. Don't be bored with repetition, okay? There is power in repetition. There's power in repetition. Open your mind, open yourself, and learn. So after the break, we will get into the types of machine learning. I'll see you after the break. We are back and ready for the second gear. All right. Thank you, Timothy. Timothy is back. Newman is back. Nyapandi is back. Lami, Robley, Lois Ominde, Darlington Okoka, Paul, Destiny, Isimami, of course, Aloha Femi, Anozi, and welcome back to the lesson. We want to move to the next gear. This time, we want to look at the types of machine learning. We've been introduced to what machine learning is. We are now clear that this is artificial intelligence that learns from data, and there are types. And so we are going to discover that there are 3 types of machine learning. 3 types of machine learning. So that is what we have in the diagram here at the right. And the first one, who can type the first one in the chat for me at the top? The first one is called supervised learning. This is the first one we are going to look at. And today we will also look at the second one. And the second one, if you look at the diagram at the bottom right, it is called unsupervised learning. Unsupervised learning. Please type that in the chat as well. So we have supervised learning, we have unsupervised learning. So we'll be looking at these two today. In our next lesson, we'll be introduced to reinforcement learning. So the machine learning we've been hearing about, there are three types. Three types. The AI that learns from data, there are three types of them. And these three types here are supervised learning, unsupervised, and reinforcement learning. Each type of machine learning has a different approach or distinct approach to how it processes and learns from data. So when it is learning from data, you can choose to do it in three ways. We have supervised learning, unsupervised learning, and reinforcement learning. Sometimes you don't have a choice. You have to do it in a certain way. And so there are three ways to do it. Now, sometimes there is a fourth way. And this fourth way is actually sometimes very, very powerful. And it combines both supervised and unsupervised. And we have written it right now on this particular slide. And if you can see it, please type it. Please type it. It is called semi-supervised learning. And so sometimes we use supervised to teach the model something. Then we tell the model, okay, you've had enough, you've learned enough, continue the rest on your own. You see, sometimes the data you have, if you say you want to feed all to the model, you will not have even the time to do it because we are talking about big data. We are talking about a lot of data. And so sometimes you will train it with some and tell the model that I've taught you what you need. Now do the rest on your own. What are we talking about? We are talking about the learning process. Sometimes you can be trained to a level and you can be left to continue your training. You can be left to continue your training. So we'll look at three types of training and we will learn that the first one is called supervised learning. And all of these are talking about how the machine learning is done. One is supervised learning, and we are just talking about how the training is done. So this is a supervised training. You can also call it supervised training. Now, the supervised training or supervised learning is a type of machine learning where the training is done with labeled data, period. Now, all the machine learning work with data, but there is one type that we give answers or we label the data. In other words, we tell the model that what you are learning, this is what it is called. So look at the answers right now and learn from the answers. Later, I will ask you questions without the answers, and then I will see if you remember and you can predict the right answers. Sorry. So over here, you can see that we have a diagram here, and this is the data set, and it is labeled. So you can see that the data is made up of shapes. Now, these shapes, you are not telling the model to know what they are. You are telling the model that, wait, I'm going to tell you. I'm going to tell you this shape, what is it called? Where's my mouse? This shape, if you can see my mouse, what is this shape called? This one. What is it called? It's called rectangle. You see, Let me tell you about this machine learning model. When you build a model at first, it's just like a baby. You have to start teaching it little by little. So you tell the model that this shape, look at it carefully, is called rectangle. This shape, look at it, it is called what? Triangle. This shape, it is called circle. This shape, it is called hexagon. Sometimes I'm going to ask you a question. Do we teach people like this? Do we teach people like this? Okay, someone says yes. Okay, you can teach someone by telling them what these things are called. Right now, we are not teaching a human, we are teaching a machine. And so if you come here, you are going to see that this machine is going to learn. This is what we call machine learning. This machine here is going to learn. This machine is going to learn. It's going to learn. Out of the little instructions you gave, and you told it what they are called. After the machine learning, we have a model. This is an AI model. Now look at this model. Look at this model. This model is now intelligent. Now we are testing it, or we are asking a question. We are saying that this thing, what is it called? Did we add the name to it? During the testing, did we add the name? Did we add the name? No, we didn't. No, we didn't. But look at the answer. Was it able to get it right during the prediction? Was it able to get it right? It got it right. But I'm going to ask you another question. When did we give it the name? When did we tell it that this shape is called triangle? When did we tell it that? When did we tell it that it's called a triangle? We told it during the training. This was the time we told it to learn during the training. This type of training is called supervised training or supervised learning. This is one type of machine learning. It is called supervised learning, where you learn, where you teach with examples or with names or with labels or with the answers. So the model that we built in our previous lesson, would you call it a supervised learning model? Did we provide it with the answers during training? Yes, we provided it with the answer during training. So when you are asked, what type of machine learning is this? This type of machine learning, it is called supervised learning. That's all. Now, we are going to build another model and we are going to train it. This model, we are training it with vegetables. And we came here and we said this vegetable is called carrot. This is called tomato. This is called bell pepper. So machine learn. After you learn, I'm going to ask you this one. I'm not going to tell you what it is, but what is it? And then it is able to tell you that this is carrot, this is bell pepper, this is tomato. Wow. This is called supervised learning. In this image, the model is given a set of vegetables, carrots, tomatoes, and bell pepper, along with their correct names. By learning from these labeled examples with their correct names, the model now understands how to identify each vegetable. Later, when presented with new vegetables without labels, it can accurately predict their names based on what it has learned. This is called supervised learning. I'm going to ask someone, do you understand this? Okay, someone says, yes, I understand. All right, that's all. So this is called supervised learning. All right. So each example in the training data includes both the inputs and the outputs. The inputs are called features, and the outputs are also called targets, and represented with Y as output and X as input. Capital X and lowercase y. So during the training, both the input and output were provided, allowing the model to learn from them and know their relationship. Just like we used in our first project, we gave it the input. We provided it with the input. We trained it with this. We came here and we said, take this as input, and this is the output, learn. Then we also went through this. We also went through the next one. We said this is input and this is output, learn. This is inputs, this is input, and this is output, learn. So we train it with a lot of data. After we train it, now you only give it input, don't give it output. It will be able to tell you as it becomes smarter. This is how it is. So this is supervised learning. So there's a project. Okay, this is a previous project, and this was a supervised learning model that we built previously. We've already gone through this. Now, the key idea of supervised learning is that the model finds patterns in the data to map inputs to correct outputs. So actually, behind the scenes, it is using an algorithm and a mathematical formula to map out the relationship between the input and the output and learn from the pattern it sees. After it sees that pattern with a line called regression line or line of best fits, it will be able to predict. So behind the scenes, it does it with mathematics and statistics. It does it behind the scenes with mathematics and statistics. So next time, after it has drawn this line, if you are able to ask it with a size of 2000, it will follow the line and it will make the prediction and tell you the price. That if the house has 2000 square feet, then the price is somewhere right over here, which is about 430,000 US dollars. So that is it. All right. So this particular model here, also supervised learning, we trained a model with cats and dogs and we labeled them and then it learned it. Later, we were able to give it images and it was able to predict that this is cat, this is dog. In this image, the model is provided with labeled examples of cats and dogs, where each image is paired with its correct label. So the cat has its label, the dog has its label. By analyzing these labels or labeled examples, the model learns to distinguish between cats and dogs. Wow. Once the model is tested using new unlabeled images of cats and dogs, based on its learning, it predicts the correct labels for the test images, demonstrating its ability to classify new data accurately. So during supervised learning, sometimes we ask for predictions. I'm going to say something new here. Sometimes during supervised learning, we train the model to predict, and other times we train the model to group. Let me repeat that. It's very, very important. Sometimes we train the model to predict trends in the future. And other times we train the model not to predict a trend, but to group. The second example, or the second thing I said, is that we train the model not to predict, but to do what? But to, I want someone to type it for me, just one person. To group. All right, what do we mean by group? When we say group, we are telling you to separate or identify the different groups. So you can see that this particular model of the cat and dog, we are not trying to predict in terms of a number in future. No. We are trying to group. I like the word categorize. Find out whether this image is part of group A or is part of group B. So sometimes during machine learning, we don't want to predict, we want to group or categorize. Listen to this carefully. Under supervised learning, we call this classification. Whoever heard me should type it in the chat. Under supervised learning, we call this classification. Thank you, Marasi. So in machine learning, you are going to start hearing the term classification. Classification means grouping in supervised learning. So someone will say that they want to do classification and not prediction. This means that the output of the model is a matter of classifying or categorizing or grouping. Very, very important. And so this particular model, its job was to group. Its job was to group. I'll explain more of that. So let's take a pop quiz. And I think I'm going to make it 1 or 2 questions. And then we will jump to unsupervised learning. And then we will have a model to work on. And when we get there, I'll tell you how that will go. For now, I'm going to ask you a question. Which field of computer science focuses on teaching computers to learn from data? I'll end the question there. Who can tell me? Which field of computer science focuses on teaching computers to learn from data? When we started this class, if you were not here, AI is computer science. If you are into AI, you are into computer science and you are a computer scientist. So I'm happy that you are not saying artificial intelligence, because the question is very, very precise. It's saying that learning from data. The moment you hear learning from data, the answer is machine learning. So you all got it right, and that is so impressive. Question 2. Which machine learning algorithm is used for predicting continuous numerical values based on input features? Which machine learning algorithm is used for predicting continuous numerical values? I like the questions. The questions are so specific. So if you have studied something about algorithms, you will know that predicting continuous numerical values, the best algorithm, the question is asking you which algorithm to use, is linear regression. Wow, I like that. I like that. Last question. In machine learning, when a model is trained to make predictions or decisions based on labeled training data, it is called, oh my God, this class is fun. I can't wait for us to grow in this class. I can't wait for us to advance. I can't wait for us to advance. I love this class. I love it. I love it. The answer, you all got it right. It is supervised learning. All right. So I'm going to skip the demo for last because we are going to be building a particular model. And to build that model, we are going to introduce another algorithm for supervised learning. And The same cat and dog issue, you can see that it's coming here. And if you come into this particular project, project 2, which you should also save as part of your portfolio, into bracket here, in parentheses, we say cat versus dog what? Cat versus dog what? So the task is a classification task. And we are going to import a particular algorithm for that. So let's skip this for now. We'll get back to it. And it is classification. Right now, let's jump into unsupervised learning. And we'll come back to supervised learning and build a model if there's time. Now, what in the world is unsupervised learning? We understood that machine learning is AI, where the AI is built through learning from data. And we have learned that there are 3 types of learning from data, or there are 3 types of machine learning. One is supervised, and we have confirmed that even humans are trained this way. How about machines? There's another type of training called unsupervised training or unsupervised learning. Let's look at it. Unsupervised learning is a type of machine learning where the algorithm learns from unlabeled data. This is interesting. It learns from what? Let me know in the chat if you can see this. It learns from what? Unlabeled data. Now, if it learns from labeled data, we call it supervised learning. But if it learns from unlabeled data, how is it going to do that? We call that unsupervised. We are going to see whether it is interesting or not. When we are done, I'll ask you whether you find it interesting or not. So look at this machine. We just gave it data unlabeled, and it was able to learn, and the results is here. You can see that it has clustered them. It has clustered them. It has clustered them. I'll tell you why I use the word clustered. Now watch this. In this case, the algorithm tries so hard to find hidden patterns or relationship in the data on its own. Wow. Please type on its own in the chat for me. If you're in the class, type on its own. On its own. I want to see those who are in the class. Some people are driving. Some people are eating. Some people are on their beds. On its own. What type of training do you allow someone to do on their own? Let's see. We call it unsupervised machine learning. Just like humans. Okay, so let's compare this to humans. Is it possible? I'm going to ask you a question. Is it possible? Listen to me carefully this time. Is it possible for you to learn something that you were not told, but through observation, you were able to know that this is this and this is that? As a human, have you ever learned that way before? Anybody? You were not told the answer. You were not told. Wow. A lot of people are saying yes. So computers in machine learning, they are also given that ability that, wait a minute, just look at it. And you yourself try and learn it. I'm not going to tell you. Try and find the patterns and relationships. One person went to a certain conference He met a lot of people in suits. He has never seen them before. And he saw all these people in suits. But as the event was going on, he continued to look at these people and he realized that there are three categories of people. And he was able to group them in his mind. Nobody told him, and he was right. We are not talking about strange or spiritual things. We are just talking about you as you are learning. Let me tell you, babies learn a lot without you telling them. Is it true? Is it true? Babies learn a lot without you telling them. It's true, right? They can learn by looking, by observing. We call that unsupervised learning. So in machine learning, the model is given a set of unlabeled data. I don't know which example I'm talking about here. Maybe this one, I don't know. And it groups them based on hidden patterns and hidden relationships and similarities. Group similar pictures of animals together. So I don't know which picture I was supposed to show. Was it this? Okay, fine. So there's a type of machine learning where you just give unlabeled data. And the algorithm that you would choose, so you see why we have different algorithms. Each job is to look at them and just look at them carefully and try and find patterns. Okay, this one looks like this. This one looks like the other one. This one looks like the other one. So at the end of the day, you can see that it has been able to group them correctly by studying them carefully on its own. So the machine is able to use a lot of algorithms to understand that these things, there's a relationship between them. Nobody told them, but at the end of the day, it was right. It was able to group the onions. It was able to group the, what is this? What is this one called? What is this one? Eggplant. Okay, that's right. It was able to group the eggplant and the bell pepper. So in the image, the model is given a set of vegetables, onion, bell pepper, and eggplant, without any labels or predefined categories. By analyzing patterns, usually we use hidden patterns and relationships or similarities in the data, the model is able to group, please type group in the chat for me. It is able to group similar vegetables together based on their features. Wow. Such as the shape, the color, or any pattern it was able to find on its own. But at the end of the day, it was right. The computer did that on its own. It was able to group them. Later, when presented with new vegetables, it can automatically group them into appropriate group, or I'll tell you the right word to use. Even without prior knowledge of their names. Listen, it didn't know the names, but I was able to group them. This unsupervised learning, after hearing it this way, does it make sense to you? Anybody? Does it make sense to you now? Wow. So you can see that, wow, this really makes sense. Unsupervised learning. Even we humans, we learn that way. So we do supervised learning as humans, and we also do unsupervised learning. All right. Now let's look at some key techniques in unsupervised learning. This word here, clustering, please type it in the chat for me. Clustering. Thank you, Robley. Clustering. Clustering. Yes. This is one terminology that I want you to take home tonight. Okay. I want you to take home tonight from the camp of unsupervised learning. And I'm also going to give you one word from the camp of supervised learning. At the end of the day, you realize that they are similar. So I'm going to give you two words. One is called clustering and one is called classification. This is why I asked you to type classification, and now we are going to look at clustering. Pay attention. While both clustering and classification involve grouping similar items, they are used in different types of learning. Okay, wait a minute. What we are saying is that clustering and classification, they are all terminologies in machine learning, and they all do the job of grouping similar items. That's the job they do. But there is time to use the word clustering, and there is time to use the word classification. In supervised learning, grouping similar items is referred to as what? In supervised learning, grouping similar items is referred to as classification. So please take note as a machine learning student. Where the algorithm is trained on labeled data, so you can see that we highlighted labeled data. Labeled data. So this tells you that we are not missing words at all. We are talking about we are specifically talking about labeled data and supervised learning. So the word is this, it's called classification. In unsupervised learning, grouping similar items is referred to as what? So take this home today. You've heard two words, clustering and classification. In the camp of unsupervised learning, the process of grouping similar items is called clustering, where the algorithm identifies groups or patterns in data without any predefined label. So when there is no predefined label, it goes through the process, and that process is called clustering, so that it will be able to give us their distinction. But when the labels or the items are labeled, it is classification. That's beautiful. And this clustering is one of the most common techniques in unsupervised learning. Clustering is a process where the algorithm groups similar data points together into clusters. So it does it into clusters. And so this is why it is called clustering. It does this by analyzing the features of the data and finding all without the use of labeled data. Just like the person who went to the conference was able to look at all the people in suits, but he was able to see three different types of people. Some were more finer, or some were more wealthier than others just by looking at them. And he was able to know and separate them from the others who were wearing suits, but we could see that these were bosses. This group, they were bosses, they were seniors, they were investors, and these were people coming to pitch something, or this. He was able to group them without being told. And at the end of the day, he was right. He was right. Okay, let's take a quiz, and I'm gonna give the project as an assignment. So question one, which of the following machine learning algorithms is used for predicting the category or label of a given data point based on labeled training data? Let me take the question again. Which of the following machine learning algorithms, because I'm going to give you some algorithms, which one is used for predicting the category or label of a given data point based on training data? A lot of people said C. Let's check. And the answer is classification. All right, so this is called classification. Number two, which of the following machine learning algorithms is commonly used to classify or predict the category or label of a given data? I don't know if I'm repeating the same question. Am I doing that? All right, let's look at the question again. All right, I think the question is not right. It's supposed to be unlabeled data. Sorry, no, it's labeled data. The question is correct. Now, this one here, yes. Over here, we wanted you to remember the word classification, because here we are talking about predicting the category, you see, with labeled data or with supervised learning. It's called classification. Over here, we wanted you to choose an algorithm that can be used for classification. And the algorithm that can be used for classification, that is supervised learning, is logistic regression. Yes. So that is it here. And this is the difference between supervised learning and unsupervised learning. These are two different ways systems are trained. Let me quickly mention the projects and then we will end the class. So this logistic regression, you are going to use it for classifying data into categories. You see, it is an algorithm you can use to classify data into categories based on their variables. So your job is to build a supervised learning model that can classify cats and dogs, between cats and dogs. It can separate cats from dogs. So in our next lesson, we are going to put this project in the next lesson for the sake of the video recording, so that we will look at how we're able to build a supervised learning model by training a model to classify cats versus dog. So we provided data that gives different animal weights. Based on the weight, it was able to group cats and dogs. And this is wonderful. So we'll keep working from one level to the next, stages by stages, and we will learn and we will know machine learning. We are all going to be very good in machine learning. I can't wait to see you master this, because this is gold, and I want you to get it, and it's going to pay a lot. So thank you all for joining this machine learning class. I believe it has been enlightening and you've heard new things today. Have you heard anything new today? Anybody? Have you heard anything new today? And someone says yes. So I'm very happy to hear that someone has learned something new. And let's keep learning. The goal is to be consistent. The goal is to be consistent. So please, let's be consistent. Let's be consistent. Yes. So thank you very much. And we will meet. And I'll see you in the next lesson. I wish you all the best. Have a good night. And bye-bye.